So today we're going to start looking at comparing polynomials. And what we're going to be doing with this is using information we've already looked at in previous lessons for this unit and applying that knowledge to compare different pieces of polynomials. So you might be given a graph or information about a function or a function itself or a table and asked to compare things that we've already looked at with each other. Okay? So let's show you how this works. So number one, it says we're comparing two functions, h of x and k of x. All right, we want to figure out which of these two functions has a greater number of extrema. So extrema, again, are the peaks and valleys of a graph. All right, so in the first graph, we see this one valley, so this has one extrema. Here, in the information here, let's dissect what we've got. So we've got a cubic function, which means it's x to the third. Okay, the a value is less than 1, so that means it's going to be a negative. And there's three distinct row roots, so that means that the graph will cross x-axis 3 times. Okay, so let's look at what this, we can sketch kind of a graph to see what this will look like. So it's an x to the third, but it's negative, so it's going to start up top, and it's going to cross the x-axis 3 times. So there's 1, 2, and 3. Okay, so because we have our x-axis it's crossed 3 times, what we end up with is 1 and 2 extrema. So we have one peak and one valley. So we have 1 and 2 extrema. Since 2 extrema is bigger than 1, we can circle this side of our function, or sorry, this function, all right, as being the correct answer. All right, and that's it. So showing your work is just showing how you found out the different information. Okay, let's look at number 2. In number 2, we are finding, we have s of x, which is got that table, and we have t of x, which is this function. We want to find out which one has a greater average rate of change for the interval of -1 to 1. So -1 to 1 means we're going to use this point and this point. These are basically points on a graph. We want to find out the slope basically between those 2 points. So we use our slope formula. So it's y2 minus y1 over x2 minus x1, which gives us 6 divided by 2, and the slope will be 3. Okay, so that's the slope for the table. For the function, we don't have the points yet, but we can find them out by putting 1 and -1 into the x values of our function to find the y's. So let's show you how this is done. So we have 0.1 times 1 cubed minus 1 squared plus 2. Okay, and that gives us, if we put it in our handy dandy calculator, we have 1 cubed minus 1 squared plus 2 is 2, and then times 0.1 is 0.2. So this is 0.2. Okay, so our point then will be 1 comma 0.2. Okay, 1 coming from the one we put in for the x's. Now we've got to do the -1. So we have the same idea. Put -1 in for the x's this time. And when you're putting this in a calculator, it's really important now that you put the negatives in parentheses before you square them and cube them. So we have -1 cubed minus -1 squared plus 2. It's a 0 times 0.1, which is still 0. So our second point is -1 comma 0. Okay, so now we're kind of in the same spot we were for the table on the left. We have our 2 points, now we're going to find the slope. So we have 0.2 as y2 minus 0 over 1 minus -1 gives us 0.2 divided by 2, which is 0.1. So that's the slope, 0.1 versus 3. Well, which one is a greater average rate of change? We want to figure out which one is steeper. Whether it's positive or negative is irrelevant. We want to know the steeperness. Well, 3 is a lot steeper than 1, 0.1, so this is our answer, 3. All right. Next, analyze the two functions. Circle the polynomial of h of x and p of x, which has a greater number of extrema. So we're looking for extrema again. We're looking for the peaks and valleys of a graph. So this has a peak, a valley, a peak, and a valley. Okay? So this has 4 extrema. All right, now let's look at the one next door. We have a quadratic function, which is x to the 4th. And it has 4 distinct real roots, which means it has a cross the x-axis 4 times. So if we draw a sketch of this, and it doesn't say if it's positive or negative, it doesn't really make a difference. So we're just going to draw a x to the 4th graph. So it's got 1, 2, 3, 4. We're going to count the extrema. So there's a valley, a peak, and a valley. So there's 3 extrema for this graph. Oops, that was ugly. So the 4 extrema beats out the 3 extrema. So there we go. All right, moving on. So we have circle the polynomial. We have r of x and t of x, which has a greater average rate of change for the interval of -3 to -1. So just like the one in number 2, we're going to find the average rate of change by putting these values in for the x terms. So we have 3 times -3 cubed and -3 squared plus 1. Again, it's really important that you put these values in parentheses when you plug them into the equation. So I'm going to put it all in at once to find out what it is. I'm going to put parentheses around the -3's, and all the parentheses that are written down that I've done here, I'm going to put in the calculator. So I have 3, and parentheses, -3, then to the 3rd power, then another parentheses and another parentheses, -3 parentheses squared, plus 1, close parentheses. Okay, this is negative equals -810. Okay, so our point would be 3 comma -810. Sorry, -3. All right, now we put in -1, so we do the same thing. So I'm going to put that back in the calculator. So we have 3, and then parentheses -1 to the 3rd power. And I have -1 squared plus 1, close parentheses. And that is -6. So I have -1 comma -6. So when I find my slope, I have y2 minus y1 over x2 minus x1. I'm going to put -810 minus -6 as my y's, and then -3 minus -1 there. So if I figure this out, so I have -810 plus 6, I get -804. And then -3 minus -1 is -2. So if I divide that by -2, I get positive 402. Okay, so that's the slope for that. I have a feeling this is going to be hard to beat on the other side. All right, and in this case, what we're going to do is we're going to look at the points on the graph. Okay, so we look at this, we're looking at -3 to -1. So -3, if we look at the x of -3, that's at this point of positive 4. So we have -3 comma 4 as our first point. And then -1 comma 0 is the next point. Now obviously it's going to be hard to beat 402, but we have to show the work to show that we know what we're doing. So we got 4 minus 0 and -3 minus -1, which is 4 over -2. So I have -2 as my slope. Well, -2 is not as steep as 402, so that's going to be my greater average rate of change. All right, moving on to number 5, which has a greater relative maximum. Okay, so relative maximum is we're looking for the highest point. It doesn't have to be an absolute, just the highest point on the graph that we can see. All right, and it doesn't just keep going on. So this part keeps going on towards infinity. That's not what we're looking for. We're looking for this point right here. So it's about, let's say 19.5, right? Okay, so that's the relative maximum there. So we want to do here quadratic function where, so quadratic is going to be x squared. The a is less than 0, so it's going to be negative, and has one real root. Okay, so this is an important piece. This one real root means that crosses the x-axis one time. Okay, this only happens with quadratics in one particular instance, and that is where the vertex of the quadratic graph is on the x-axis itself. And since it's negative, it's going to hit once there and then go back down. So this is at a y of 0. So in this case, 19.5 is bigger than 0, so this has the greater relative maximum. Okay. If this was any higher as the quadratic graph, it would have two x-intercepts, so it would have two real roots. Since it can only have one, it's got to hit the x-axis and then bounce back down. Right? So it can't be any higher than that. All right. Last example. We have s of x and t of x. All right. So we want to find from 0 to 2. So from 0 to 2, these are our points. Okay, so we have 7 minus negative 4 over 0 minus 2, which gives us 11 divided by negative 2, which is negative 5.5. We're going to make these as decimals to make it easier on ourselves. Okay. Now we have to find out 0 and 2 for this function. So I'm going to put 0 in for the function. All right, so 0 cubed is 0 times 2 is 0. 0 squared is 0. So I'm going to be left with 7, and then this negative sign on the front of it makes it negative 7. So my point for here would be 0, comma, negative 7. All right, then we're going to put in, what was the other part? It was 2. So I'm going to put in 2 for my function. Put this in the calculator. So I have 2, and then 2 in parentheses cubed, minus 2 squared, plus 7, and it's going to equal negative 19. So I have 2 comma negative 19. So if I find the slope of that, I got negative 19 minus negative 7 over 2 minus 0. Now, some people might be asking, well, for the last one you did, the y one, it doesn't make a difference which one you do first as far as the order of the slope thing, as long as you're consistent. Okay, so I could do y1 minus y2 over x1 minus x2, or I could do y2 minus y1 over x2 minus x1. As long as you're consistent where the x's or the 1s and the 2s go, you're fine. All right, so moving on, we have that's going to be negative 12 over 2, which gives us negative 6. Well, negative 6 is a steeper slope than negative 5.5, so this would be your answer. Okay, so all you're doing again for these problems is just comparing the information you can get from either the graph or the table or the equation or the information you're given about the function, and then compare what they're looking for in the problem, and then circle the answer that best fits what the question is asking. All right? Good luck on the practice.